All right, hey everybody, welcome to our very first study group. Couple things I wanted to talk about first. Let's see. All right, so a good place to be right now is roughly done with running Jupyter Notebooks locally. Today's material for this study group will mostly be going through stuff from right after Jupyter Notebooks to the end of topic 1. If you have any questions about the setup, I know several people have already slacked me with issues, which I will address later. There's actually one really common issue that I'll talk about. But if there's anything else that comes up, feel free to slack me or slack the channel. Cool. Now, one thing I wanted to talk about before getting into the material is where can we find my study group materials? So in the homeroom, under resources and links, you'll notice that there is a link for study group repo. So I mentioned really quickly yesterday that a repo is basically a group of files that live on GitHub. Repo is short for repository. So all of our study group materials will live in this study group /092820FT repository on GitHub. Now, these steps might look kind of familiar because these are the same steps that you had to do to get the environment set up. But basically what we can do here is clone this repository down so you'll get to follow along these notes as well. Whether you want to follow along now, I actually know that most students will download these only after the fact. But yeah, these are just good to have. And the way you do that, actually, let me change to share my screen so you can see my terminal window as well. And if y'all can't already tell, I'm a Mac user, so sorry to Windows users. Anyways, the way to get these notes on your own screen or on your own computer is you're gonna wanna clone this repo down. Let me just make this text a little bigger so y'all can see. A little bigger. All right, cool. All right, so when you open up your terminal or your Git bash, first you have to decide where you want to store all of this material. And so I actually made here a folder called DS where I store my stuff. So some basic Git commands, if you do pwd, it means print working directory. Basically shows you where on your computer you're at. So right now I'm just in my base folder. On a Windows, it would have like that C drive with like the name of your computer and like the name of a user, something like that. But pwd will show exactly where you are. Another helpful command is ls, which basically lists all the folders or files of where you're in. So it's gonna be kind of messy, I think, but you can see that in my base directory, I have all of these folders. I have like my applications, desktop, documents. I have this that I use for one of the labs that I cloned down as well. And you can create new folders. And yeah, ls just shows you all the folders that you have. So I actually made this folder called DS, and that's where I store all my data science things. So to get into a folder, you do cd, which stands for change directory, and then DS. I like to make my folder names as short as possible so I don't have to type that much. So cd ds. Now by ls again, I can see that these are actually all the files starting from here. These are all the things that are in my DS folder. Well, cool. Within here, let's see how I can clone my study group notes down here. So let's say I just wanted to have my study groups notes in this DS folder. What I'll do is type in Git Clone. On GitHub, we're gonna copy this specific link in code and clone. Make sure it's HTTPS. Copy this and just paste the URL in here. And when you press enter, it'll automatically write all the files. If I do ls again, you'll see that now I have this study groups folder here. And same as we did just now, we're not in the new folder yet. We just have to change directory into study groups. A neat tip, because this folder name is kind of long, there's tab autocomplete. So if you press tab, it'll autocomplete the folder name. Super useful. Especially, I know a lot of those lab names are really long. So other than that, you can sort of see that I am already in this folder. Just to check, do a pwd. With the pwd, you can see that I went into DS, went into the study groups folder. Then when I do ls again, you'll see that I have the readme file and the phase 1 folder. And so all the materials for phase 1 will be in the phase 1 folder. So to do that, we can cd into phase 1 again. Great. And now when I ls, you'll see I have this notebook. And if your environment was set up right, you'll be able to type Jupyter Notebook, and it will pull up here the Getting Started notebook. And you can click along, click this, and follow along. And it'll be the exact same thing I'll be going through today. Any questions so far? This stuff, dealing with the terminal and Git, we'll be going through more in detail tomorrow, because that's topic 2. But any questions so far?
Excuse me, we don't need to set up our environment every time we use this thing. For example, it was a command like source something or
yeah, you actually do not
environment.
Yeah, you don't have to set that up all the time. So what you had done in this lesson here, so the lesson that was, I think it's the Git and Anaconda lesson, what you had done, if you remember this line that you set up a bash profile. So in your bash profile, what a bash profile is, it is basically in your bash profile, let me find that. You wrote this line in your bash profile. And let me zoom in a little bit. Here we go. All right. So you did basically basically added this line to your bash profile. And what that does is every time you open up your Git bash or your terminal, it'll run everything in your bash profile first. So what that means is every time you open up your terminal or your bash profile, your learn environment will automatically be activated. Does that make sense? Cool. Awesome.
Thank you.
You're welcome. Any other questions? Great, let's get into topic 1. Awesome, so getting started with data science. These I briefly talked about yesterday, but I'm just gonna go through them really quickly. We had downloaded Anaconda, which is a package management system. Basically, if you are missing a package, like earlier on the Slack channel, I saw that there were some errors coming up where they couldn't find a package. You would just conda install that package. So Anaconda helps you look for packages and downloads them into your computer. Git is a version control system. And Git works with GitHub because Git gets new files and new changes from GitHub onto your local machine. Jupyter Notebook, this is a Jupyter Notebook. Python files we'll deal with a little bit later, and virtual environment is basically what we had set up. We set up our learn env, and what the learn env has is all the correct versions of packages that we're going to use throughout our course. Questions on these terms so far? Awesome. These errors, I'm actually really glad none of you had these errors. So we recently redid those few lessons, and I don't think any of you had these errors. One common error that was coming up today and yesterday is some of your Git bashes weren't, what's the word? It wasn't initialized to run bash or conda or something like that. So basically, bash is a shell language, and there are many different shell languages. So by default, I think if you're running a Mac and you're on Catalina, your default shell is actually Z shell, which is a different shell language from bash. Other shell languages include PowerShell. I honestly can't think of anything else, any of the other ones right now, but the main one we use is bash. You can very easily learn how to use the other ones. It's just slightly different syntax. It's slightly different commands to work with Git. So that common fix, that common error that we've been having, to fix that, you just have to type conda init bash. And let me just put that here. Actually, let me use this to make sure we don't. All right. If you have like a not ready to run conda or something like that, conda error, you would just type conda init bash, and that should work. I think this error comes up when some of you try to do your conda activate learn env. So look out for that. All right, so that's all with the setting up environment. If anyone has trouble setting up their environment by today, highly recommend just let me know and I'll help you out through that process, because every operating system is slightly different. All right, so today we're just gonna do a Python 101, an overview of all the Python data types and collections. And as a quick overview, the main data types we'll be talking about are strings, numerics, booleans, and variables. Collections are lists, dictionaries, sets, and tuples. This lesson is basically going to go through what each data type is, what it's used for, and the different methods and functionality each one will have, because these will come in handy when we're working on lessons throughout the entire course. And then really quickly, we'll look at logic flows. All right, first up, strings and string methods. Something that I really hope you all get used to doing is reading documentation. Documentation can be very, very intimidating to read. But in order to learn how to use like the thousands and thousands of Python packages out there, you got to get used to reading documentation. So usually what I would do is I would just look up Python string documentation, and it'll pull up something like this. And these are all the Python built-in string methods that you can use on any string at all. So for example, we have the string, and string is anything wrapped in quotes. It can be single quotes or double quotes, sometimes even backticks. But it doesn't really matter which one. Just make sure that you're opening and closing your string with the same one, because that does cause problems. So here we have just a string welcome. Issues with using the wrong opening and closing, syntax errors. So just watch out for that. If you have something with an apostrophe in it, you should wrap it in double quotes. So Flatiron Schools students. There we go. If we have an apostrophe, if we decide to wrap our string in single quotes, you can sort of see here that just based on the coloring of the Jupyter Notebook, it's a little bit off, right? And I think it'll throw you an error as well, invalid syntax. So make sure that your quotes are the same quotes opening and closing. That is surprisingly an error that tons of people run into. So let's just do this the right way. Flatiron Schools students. There we go. So welcome to Flatiron School. We're gonna take a look first at the dot replace method. So what does dot replace method do? How does it work? Let's take a look at the documentation. So let's look for replace. And replace returns a string where a specified value is replaced with a specified value. That's pretty straightforward. If you click onto the thing, it tells you exactly how to use it. So usually there'll be like a syntax and parameter values section, and that's usually what you'll look up. So you can see that how it works is you'll use string and then dot replace. So there are some methods that work by doing like replace and then you put the string inside of it, versus some of them you put like the string and then do a dot replace. If anyone gets that difference, you'll probably run into it soon. But that's why it's important to look at syntax. So in syntax, it shows you what parameters the method takes. So replace is a method and it takes in these parameters. Old value, new value, and count. And for parameters, there are always required parameters and sometimes optional parameters. Required parameters, the string to old value and new value, which are basically the string to search for, the string to replace the old value with, and count is optional and it tells you how many occurrences of the old value you want to replace. Default is all occurrences. So usually if you have an optional parameter, there will be some default. Let's take a look at this dot replace function. So here I'm replacing all O's with X's, but only twice. And so if we run this, it's kind of what we expect. The first two O's were replaced with X's and the rest of the O's stay the same. And so let's pick a different method to see how it works. go back. And another pretty common one, let's see. Let's take a look at strip. Strip returns a, it removes the spaces at the beginning and at the end of the string. I'll tell you now, I remember maybe only 5 of all the string methods, if any. So it's very, very normal. You definitely don't have to memorize all of these methods. That's what the documentation is for. So let's take a look how strip works. So it looks like you have the word banana, but with a bunch of spaces at the start and at the end. And when you do text.strip, you're gonna get, let's take a look. X is text.strip, and if we print that, of all fruits, X is my favorite, and you can see that there are no leading and ending spaces. Let's make that a little clearer. Let's make a new string just to demonstrate how this works. Let's get rid of this window. String.strip characters, it says which characters to remove as leading trailing characters. All right, so as an example, let's say we have space, 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 Latin school students. That's our string. If we do, let's call this test for now. If we do test.strip, we just expect all the spaces to be removed. Surprisingly, a useful function because sometimes when you get text data, it's never clean. So that is something that you might want to look out for. So there are like tens and tens of string methods.
Can you strip other things that aren't spaces?
Absolutely, yeah. So let's take a look. Let's use an example of, I think, let's try this. Let's see what happens when you do this. If we do just S and we run test being like this, I think this should get rid of all the S's. Yeah, so all these trailing S's will be gone. And if I put like S's at the start here, I think all the S's will come up as well.
And can you strip more than one thing at the same time?
Like, ooh, that's a good question. I actually do not think you can do this because it only takes in one argument at a time. But a really good point to bring up is that you can actually build methods on top of each other. So let's say I have all these S's and then I have, let's say, like a bunch of random spaces here. I believe you can do this. You can dot strip and then dot strip again. Let's test this out. There we go. So what we're doing here is basically doing dot strip twice. It does go in order, I believe. So let me just test this real quick. I think if I have it this way, you'll only end up stripping the S's. But if you have it like this, you can pile methods on top of each other that way. That's a really great point. Cool. So string methods. There are so many string methods to choose from. Very likely, if you're trying to manipulate a string in some way, there is a method that exists for it. So just Google it. All right, let's move on to numbers and math. Actually, let me just change the sharing so you're not seeing my entire screen. There we go. All right, numbers and math. The main data types that we have are integers and float. And in Python, very easy to perform math operations. So let's take a look first. So if you want to check the type of something, you can wrap whatever it is in the Python built-in method type. Let's look at the type of 5.
Where are you following this from on our phase 1? Because every time I go on that screen, it says it's downloading.
Oh, on the GitHub?
Not on GitHub, on the homeroom screen.
On the homeroom screen. Okay, so from the homeroom screen, let's see, from the homeroom screen, you would go to our study group repo. If you click onto phase 1 and getting started, it should load up here.
Oh, okay. Okay, I was doing from phase 1. So every time I click on something, it downloads the whole thing and brings up a new book browser.
Oh, I see, I see. Okay, well, we can talk about this later if you're still running into issues.
Okay.
All right, but thanks for clarifying. So where was I? Right, you can check for the type of anything in Python just by wrapping whatever it is in the type method. So here, let's take a look at the type of 5 is an integer. Now a float is basically anything with a decimal. So if we look at the type of 5.0, it's a float. Now in Python, really easy to do math. It's basically a calculator. So here, if I have 1 plus 5, I can do 6. I can do any math operations in Python. One little thing to look out for, sometimes you might run into issues, is when you want to sum together an integer and a float. So let's say 1 plus 5.0. It automatically converts into a float. So just to double check, the type of 5.0 plus 6 is a float. So when you add an integer with a float, the sum automatically converts to a float. Same when you're multiplying, subtracting, dividing. So plus is plus, minus is minus. To do a multiplication, it's the asterisk. To divide is just a /. And some less conventional math methods, math operations, are modulo and /. So what modulo does, modulo gives you the remainder. So modulo is a % sign and it gives you the remainder. So when you take 8 divided by 3, it divides by 3 2 times with a remainder of 2. So the remainder is 2. Sometimes helpful, especially when you want to look for even or odd numbers, you can just do modulo 2, and if it is equal to 1, is an odd number. // gives you the quotient, so it's like floor division. So it's basically you're doing division, but you round down. So 16 divided by 3 would give you 5, because it will give you 5 with a remainder of 1. Floor division, you just get 5. So numbers are pretty straightforward, just integers and floats. Sometimes you might have to convert between each other, but for the most part, pretty straightforward. Questions about, where was I? Questions about numbers? Awesome. Cool. Booleans and logic. Now this part can be a little bit confusing. The main things you have are true, false, and or, and not. So sometimes when we're doing control flows later in topic 3, we have a lot of if statements that we're checking for conditions. And when you have if statements, you're usually checking if something is true or false. And so let's say we want to check for multiple conditions. We want to see if a number is divisible by 2 and divisible by 3. And so something we would do is, let's say, let's see, 6 divided by 3, what do I want to do? Yeah, 6 divided by 3 and 6, sorry, I meant to do it like this. And 6 divided by 2 equals 0. So basically what I'm saying is that the modulo of 6 and 3 is 0. And with basically no remainder when you divide 6 by 3 and no remainder when you divide 6 by 2. So because these both evaluate to be true, we get true. So imagine we have these two conditions, and basically they'll group together like this. So anything that is true and true will return true. Now, if something is true and false, so let's say we're taking a look at if 6 divided by 5 equals 0. Any guesses on whether this will be true or false? I see some thumbs down. I see some thumbs down. That's right. It'll come out to false because both these conditions are not satisfied. And we're looking for both conditions to be satisfied if we have an and statement. So true and false will evaluate to false. Now, what about or statements? Or statements are sort of like saying, I could do either this or this. So thumbs up or thumbs down, will true or false evaluate to true or false? All right, I see some thumbs up. Right. With an or statement, if you have a true statement and a false statement, it'll still evaluate to true. All right. So now we've talked about true, false, and an or. There's the not. And the not is literally just like a negative sign. So true or false evaluates to true. And by the way, the parentheses rule for, what do you guys call it? PEDMIS? Or I forget like the order of operations acronym that we have. Parentheses always come first. So if we put a not anywhere, it basically reverses the true or false. So true or false, if I have not true or false, we have false. More straightforward, not true evaluates to false. This notebook is really for you guys to play around with and just like test different things. So feel free to do that. All right. Any questions on logic flows? There is like one part of, I want to say topic 3 that really dives into this.
Okay.
Mm-hmm.
What's the double equal mean?
Double equal?
Yep.
Yeah, that's a great question. So in Python, there's this difference between single equal and double equal. I'm actually just about to get to single equal. And single equal sign is for when you want to assign something to a variable. So single equal sign is for assignment. And double equal is checking for equality. So here we're just checking for the condition that 6 modulo 3 is equal to 0. If we just do, let's see, I think this will throw an error. If we just do a single equal sign, you have syntax error. You can't assign to operator. So basically, a single equal is trying to assign something to something. Therefore, it's throwing us an error. So
It's like for mathematical operation, you use double equal.
that's right. That's right. So just remember, single equal is always for assignment, where you're assigning something to a variable, or yeah, pretty much assigning something to a variable. And double equal is actually checking for equality.
Thanks.
Great question.
Excuse me, about
Mm-hmm.
about the documentation, and there is a built-in documentation in Python, right? Because it said if you write help parentheses str, it will resolve all the methods that you can use with strings, right?
Yeah, absolutely, absolutely. I actually don't use this too much, but I know some people do. I believe. Oh, you were just about to say something? Sorry, I interrupted.
Yeah, but it's hard to read it. For example, underline, underline, add, and underline, underline, parentheses, self value, and forward slash. I don't realize what it is. But when I search it up in Google, it recommends the W3 schools.
So you mean like these?
Yeah, yeah.
Oh,
yeah.
Oh, like this documentation versus the Python built-in documentation.
Yeah, yeah.
Okay. Yeah, the Python built-in documentation, I think this is how it works.
Yes.
Yeah, so Python built-in documentation will literally pull up like the back-end code of Python and show you what's there. So you can see here, there are all of these methods that you have here. But if you scroll down a little bit more, I think these are all the same methods that we have in the W3 schools link that I just showed you all. These double underscore methods are called Dunder methods. We actually get to this a little bit in Mod 3. These are basically, let's see, I think I can demonstrate this really quick. These are sort of like methods that are not used as often, but if you want to get like a feature of it or an attribute of the string, you can do these with these methods. I'm not too sure if this will work, but basically any of these methods will be not with like a dot strip and you put the string like at the front. So let's say, hello. So you know how like dot strip worked like that? Any of these methods kind of work like this. So for example, the most common one we have here, I see length. It returns len self. This documentation is harder to read, but if we look at the length of a string, it'll tell you how many characters it is. Most of these have equivalent methods without the dunders. But I wouldn't worry too much about these. I think if I do this, it may or may not work. I don't remember. Let me try something. don't think this will do anything. But yeah, you end up with, yeah, you can use it like this, but because the Dunder methods, I think most of them work the same way if you like just wrap the string within it. But yeah, most of these methods are little less used, and also some of them are more self-explanatory, I think. But that's a good question. I personally like to Google for my documentation rather than using the built-in because this is sometimes hard to read. It's not formatted as nicely.
Okay, thank you.
Yeah, you're welcome. But yeah, the dot dunder len is the same as doing len and then whatever the string is. Why do I keep doing that? There. But yeah, great question. Let's see.
And also, what's the difference between a method and a function? Because in the documentation, I mean, the lessons we are going through, they use it interchangeably. Are they different or they are the same?
Yeah, so methods are actually functions. I would say they are pretty interchangeable. Off the top of my head, I can't think of an instance where they are not. Usually methods are things that are built into packages. So these I personally refer more to as methods, but they are defined using functions. So they are pretty much interchangeable. I will say I use functions usually only when I'm like defining a function by myself, like to do something that I'm doing that isn't part of a package. But it's pretty interchangeable, I think.
Okay.
That's a good clarifying question. Anything else? Cool. Really quickly, variables. You can assign anything to variables. So here I've assigned 5 to 7, which let me just change that back to 5. 8.5 is the string 8.5 words, and isn't. And so you can do operations using variable names that you've assigned other things to. So 5 and 8.5, the variable 5 has the number 5, variable 8.5 has the float 8.5, so they work like whatever is assigned to them, and so we get 13.5. Words, I think I demonstrated this kind of earlier. If I do words.split, and .split, if you look at the documentation, will split up a string into substrings based on some like character, and by default it'll split wherever there's a space. So if I do words.split, you can see that split at all the spaces and turn it into a list of strings. And I can also do logic on variables. So if isn't is false, not isn't will evaluate true. Any questions before we move on to collections? And in collections we have lists, dictionaries, tuples, and one more I'm forgetting. Sets, yeah. Awesome, all right. Let's start with lists. I think lists are one of the more common ones. Lists and dictionaries are probably the most common ones. In a list, you can put anything in a list. Lists are ordered and are also mutable. Mutable meaning that you can change the elements or reassign elements in a list. So let's just make this list of like 1, 2, 3, 4, 5, hello, true. Because a list is ordered, you can pick up elements by its index number. So my list 3 will give us 3. And just remember that list indexing starts with 0. Actually, any indexing in Python starts with 0. So it'll start counting 0, 1, 2, 3. And because this list also starts with 0, you get 3 for 3. Now, lists are also destructive. There are several list methods that are destructive. That means that if I do a method, it actually edits the list. It actually gets rid of the old list and we have a new list. So here, I'm appending 8. And if I print my list again, you can see that we have 8 at the bottom. So with lists, the append function is destructive. Now, the opposite of that is not destructive, right? So what you can also do with lists, you can actually add lists together, which is something that's pretty useful if you're taking a bunch of small lists and putting them together. You can add lists to lists. So here I have my list, which is now 0 through 8 pretty much. I can add 9 and 10 to it. However, just doing this addition is not destructive because we're just taking my list and we're adding 9 and 10, but my list isn't changing. If I comment out this line, comment out basically means that that's not a line of code that will run. If I just have my list plus 9, 10, that works. 9 and 10 is added. But the variable my list doesn't actually have that 9 and 10. So how do we get that 9 and 10? Several ways to do it. We can use the .extend method. So .extend, we can add 9 and 10. So you can see here, we have 9 and 10 added, and .extend is also a destructive method. Now, we've just talked about .append and .extend. Anyone know the difference between the two? It's kind of subtle, but will prove to be something that I think will be helpful in the future.
Is append where you can put it in anywhere, and then extend you can specify, or vice versa?
That's actually a good question. I don't know about, I've never really used append or extend in other parts of the list. Let me actually look that up really quick. Python list append. And let's take a look at this method. Actually, that wasn't the difference I was thinking of, but it does look like that append only appends to the end of the list. And let's take a look at Python extend. And let's see. I like the W3 schools because I think it's just clearer. So extend methods add the list elements to the end of current list. So both of them actually do add to the end. That's a good thing. I actually didn't know the answer, so now we confirm. But yeah, anyone else sort of see a difference between .extend and .append? Right, let's do a more like apples to apples comparison.
Extend, you're extending with another list, where append, you're adding just a string in or a number.
Yeah, actually that is right. So here I did the mylist.extend 9, 10. And let me actually do this so it's a little clearer. Let's see, I have up to 8 here, right? All right, let me just copy this over and have this .extend, and we're gonna do a direct comparison with .append. And let's take a look at 9 and 10. And we'll just see what that gives us. All right, so extend does this exact same thing. Oops, actually that doesn't work. Sorry, let me change this back to my list. And then let's reprint. All right, so, let's do this again. All right, so basically why that happened is, I have my list here, I did .extend, it added 9, 10. I actually ran the cell again, so it extended 9 and 10 again. And so to reset that, I just reran my list to reset it to end at 8, and then extend it back to 9 and 10. So that was .extend. And I think I'm gonna have to do the same thing here. So let's take a look at this. So if I have my list, and I'm gonna run it again to reset it, this is what .append returns. It's a subtle difference, but the .extend, yes, exactly as Austin said, it extends a list with the elements of another list. So we're just extending the list with whatever is in here. .append will see whatever argument whatever you're feeding it into append, it'll see that as a single element and add that as a single element into the list. So the subtle difference here is you see where 9 and 10 are just a continuation of the list. In the .append example, 9 and 10 are actually now a nested list within a list. Cool. That's actually something that's pretty neat. I personally didn't know of .extend for maybe a little too long, and I was just like trying to add lists together in like just not an effective way. But yeah, so this is a list being mutable. All right, so let's take a look at what my list is now. Let's not have this version. Let's go back to this version. A little smaller. All right. So lists are also iterable. So therefore, we can run for loops through lists. So I think you might have seen this in bootcamp prep. If you do, if you're looping through a list, so for T in my list, and literally this can mean anything. I like to think of this as like a temporary variable that points to each element in the collection as the loop goes on. We'll just print T. Another pretty useful thing is list range length. List range length is something that we actually end up using quite a little bit in our when we're defining functions for different things. Let's break it down. What is the length function? What does the length function tell us? Anybody?
It counts how many items are in the list.
Exactly. So length tells us how many items are in the list. So right now, 9 items in the list. Next, what does the range function do? I don't know if this appeared in bootcamp prep or anything, but has anyone seen the range?
Starts from one and to another.
Yeah, so range actually creates a range object that basically counts from 0, unless you give it a specified start, will count from 0 to whatever number you feed it. So because the length of my list is 9, this is literally the same thing as doing the range of 9. So let's undo that. So range length my list here. And you can see it actually outputs this range object, but really what it is, if we coerce it into a list, what it does is it gives you a list from 0 to 9. And again, with Python, because of the indexing, we always stop before the number that we tell it to stop. But it's also still 9 elements in the list. So another helpful thing to have, list range my list, that's the same thing we did, is sometimes you need the index of something in whatever for loop you're doing. And a more specific example will come up in topic 3. But for some reason, you just need the index numbers for something, you can always do for I in range length my list. So here we added list range my list, and honestly, no difference if you add list or not. But Python recognizes that the range object is also iterable. So if we don't care about what it looks like, it'll still print the same thing. That makes sense? I understand I'm like introducing a lot of new things here, so at any time if anything is not clear, please let me know.
Can you expand a little bit on how loops work? Because I don't know, I guess just the formatting or the syntax of it is a little confusing.
Absolutely.
So, yeah, can you just explain like for I in and then print I? So you said I is just a variable that you can substitute anything in for.
That's right. So a loop can be run on any iterable object. Something that's iterable usually means that's like multiple elements in like a collection. So it could be a list, some dictionaries, do sets, do tuples, anything that has like a collection of objects you can iterate over, and so you can run a for loop over them. And so the syntax of a for loop is the same for any case. You're always doing for temporary variable in whatever this is. So I can also do for I in, we'll start with for I in my list. And just so we remember what my list looks like, this is my list. And for I in my list, so that means how the for loop works is it actually starts at the head of the list, so the first element. So on the first loop, I refers to 0. So how this works in Python, how Python actually reads this, is going to be like, all right, for I in my list, so I is going to first point to 0. We're going to print, actually, we're not going to print my list. We're going to print I. Let's print I first. There we go. So for I in my list, print I. So it's going to notice that, all right, first we're going to assign 0 to I because it's the first element, and it's going to print. After it finishes everything that's within that loop is going to move I to the next element. So after it prints 0, it assigns 1 to I, and then prints the number 1. And it's going to keep doing that down the list. So how a for loop works, it's going to do everything that's indented within the for loop. So anything that is right of this indent, so right now this for loop is at the very left, is not indented at all. Anything under or after this colon that is within this for loop, it will do before repeating. So if I put print assigning next I, you'll see that it's going to print I, print this line, and then repeat that process over again. So if I run this, you can see that it's doing, okay, I is 0, let's assign the next I is 1, let's assign the next I, and then I is 2, and then so on and so forth. Loops are kind of a concept that, at least for people very new to coding, as I was when I first started, took a little while to sink in. So I think it's just practice and seeing it over and over again.
Awesome. Yeah, that was really helpful. Just one more question. So for the I in my list, do you always have to put I in print, or like, because initially you said for I in my list, print my list.
Yeah, so for I in my list, it's going to assign something to I, but you can really do anything you want here. Here I'm just printing I just so it's clear what's happening, but I can say print, I, and I can like say that's what, let's see. Yeah, that's what I is. And I'm gonna change that to double quotes. And that changes. If I want, if I just keep printing my list, you can see that because I is each individual element, and in this for loop, I'm just printing the entire list every time. This entire list keeps printing at this print statement.
Gotcha, thanks. Yeah, that's really helpful.
Yeah, you're welcome. I know like the last few sentences I said were not coherent sentences, but I'm glad that came across. All right, yeah, loops are kind of confusing. There is much more in-depth stuff on loops in topic 3. So there's still time. All right, I have a feeling we're gonna go a little bit over today. So if anyone needs to leave, feel free. But let's move on to dictionaries. So just really quick, dictionaries consist of key value pairs. Very important that you remember that this is a key, this is a value. Anything before the colon is a key, after the colon is a value. Dictionaries are also unordered, so you actually cannot index through dictionaries. So let's say I have this dictionary. I can't be like, all right, I see that brand is the first thing. I can't do my dict and index 0 because you'll end up with a key error. Because the way that dictionaries works are you're actually looking up by key. So here, if I look up brand, it'll know that it's Ford. So dictionaries, you look up by the key. So they're unordered, but dictionaries are also mutable. So you can update dictionaries as well. So dictionaries have a lot of little intricacies on the way they work. Because they are unordered, looping through dictionaries is a little bit difficult as well. Let's take a look. So same dictionary that we're gonna work with. Let's just print it. We have brand is Ford, models Mustang, year 1964. Now, the dot items method is actually something that's gonna be kind of useful. My dict dot items basically turns this dictionary into a list of tuples. So sometimes you want to be able to iterate through a dictionary, and I think we'll get to that later. Yeah, we'll get to that later. But just having a dictionary as a list of tuples is a little bit more helpful, just because tuples are ordered and are immutable. And we'll talk about that even more in a little bit. So let's take a look at the type of the dictionary and the type of dictionary.items. So that makes sense. The type of a dictionary is a dictionary. But if we add a dot items, which was a method that was done on the dictionary, it actually says that is a dict items class. So it's its own special data type. Also, we can coerce a dictionary into a list. Has anyone tried this before? Does anyone know what happens when you try and coerce a dictionary into a list? Yeah, this is actually kind of annoying. But if you coerce a dictionary into a list, it only keeps the keys, which is just a fact to remember, that if you coerce a dictionary to a list, you only keep the keys. So therefore, if I'm iterating just through the dictionary, only the keys print out. So that's where dot items might come in handy. So dot items, because it turns the dictionary where it has like the key value pairs into a list of tuples. If you loop through for I in dictionary dot items, it actually prints out both the key and the value. Anyone need to clarify anything on this? There will be a couple labs in topic 3 that have you looping through dictionaries, and this is something that's really important to remember. All right, so let's just take a look at what these data types are. When you're looping through dictionary.items, the type of each item is a tuple. Well, so that just confirms what we had before, that when you do a dot items, it coerces the dictionary into just a list of tuples. And it just has its own data type called dict items, but that's not something that's that important to remember. Cool.
Does tuple just mean that there's the two values?
That's a great question. I'm actually going to get into a tuple section really quick there, but a tuple doesn't necessarily have to have two values. The good thing about a tuple is that it's immutable. So you actually cannot change any of the values in a tuple. And that just like makes sure that it maintains order. The values don't change. Like model will always be associated with Mustang. But tuples, actually you can have like 3, 4, 5 value tuples. There's no limit to the number of values in a tuple. But yeah, that's a great question, and we'll actually get to that in a couple sections from here. Cool. So let's just quickly talk about how you can add items to a dictionary. So let's create these blank dictionaries, and you'll see that when you're writing functions and like just writing control flows, starting with blank dictionaries and blank lists, something that's pretty common. So, all right. Let's just say that we want to add all the elements of this car dictionary into this new dictionary. Quick way to do it, actually let me just do it the manual way first. To add something to a dictionary, you will actually first specify the dictionary that you want to add things to. Specify the key, and so it's brand, and assign it to the value. So brand will be Ford. Oops, that's not right. There was no underscore there. And now when we take a look at new dict, Ford is there. So that's how you would do that one by one. Because this just has 3 elements, we can technically do this, but let's see how we do it in a list. So as we mentioned, if we want to maintain both the keys and the values in a loop, we have to do dot items. So for I in my dict items is what I'm doing here. And let's actually like split this up. We're looping through my dict items. Here you can see I'm doing I index 0 and I index 1. So just to see what's going on, let's print I. And does anyone remember what each I will be?
Iteration.
Can you say that again?
Iteration.
It will be the what, sorry?
With the value, right?
Yeah, it will be both the key and the value in a tuple.
Yeah.
So really quickly here, you see I'm printing I in each for loop. Let me just split this up so it's clearer. What I'm doing in this for loop is first I'm printing what I is, and I'm doing this assignment. And so because each I is a tuple, the index 0 is the key, and the index 1 is the value. Cool. So what I'm doing here is actually exactly the same as what I'm doing here. I'm saying this is the dictionary, this is the key, this is the value. And it's just a bunch of different steps. You can even do this. You could even say, all right, let's assign key to be I0, value to be I1, and then have this be the assignment. Key equals value. And this will give us the same thing. So that's kind of like splits up the steps, but what I did was I didn't do these steps of like, what's the word? I'm not assigning variables in the middle. I'm just putting these I0 and I1 directly in here to assign the new things to the dictionary. That makes sense? Cool.
I had a question.
Mm-hmm.
If you assign two variables in mydict.items, would one be the key and one be the value?
In this for loop here?
Yes.
Absolutely. And I'm actually going to talk about that 2 cells below this. So we'll get to that in a little bit. So yeah, basically, if you want to add something to a dictionary, always call dictionary first, in square brackets, put the key, and then assign it the value.
And
Okay.
excuse me,
Mm-hmm.
the output of the .items append .items method is tuples?
Yes. Yes. So each .items, when you do .items, because mydict.items is, let me just actually do this right here. Because mydict.items is a list of tuples. Each I will point to a tuple here.
Yes.
Did I answer your question? Awesome.
Yes, thank you.
Cool. There's also a .update function. I'm not sure if this will work, to be honest. Yeah. .update is not something that we use. If anyone wants to look up the documentation, do that. But .update is a function. I actually don't see it used very often, so let's not talk about that. All right. As Tim was mentioning earlier, you can actually give 2 variables into a for loop. So here, usually when you're looping through a dictionary, because we have key and value, typically we use K and V. K pointing to the key, V pointing to the variable. And so what Python is good at doing is recognizing that, all right, each iterable element in my dict.items, and let me just print that again so we can see. It knows that each element is a tuple with 2 elements. And because of that, it knows to assign K to the first one and V to the second one for every element in this list of tuples. There's kind of like 2 layers going on here. First, it knows that, all right, each element is a tuple. Next, it also checks that each tuple has 2 elements and will assign K to the first one, V to the second one. Key, value. And so, in the same way, K will automatically refer to the key, V will automatically refer to the value. And this is new dict 2, which is still empty, I believe. Let's double check. Right, still empty. By doing the assignment this way, it's populated. Cool? All right, and this is just to see what happens when you like add range length in there. Range length is what we talked about earlier with lists. So the length of my dict.items, let's take a look at what that is. Length of the .items is 3 because there are 3 pairs of key and value. The range would be 0 through 3, and so when you print I, it'll just be 0, 1, and 2. That's just like another way to, if you just play and plug in different methods, that's what happens. Cool. Questions so far? I'd say dictionaries are like one of the most important data structures to know. Oh yeah, Steven?
Is that counting this last one you just did? So that's counting each tuple as 1 value?
That's right. It's counting each tuple as 1 value. So if I had like a nested list, so let's say I had like, I don't know, like 1, 2, 3, and I had like 1, 2, 3, 4, 5. This technically has only 2 elements because they will look only on the first layer and it'll recognize the length of this as 2. So just look at the first layer. So this was also like a bunch of like different length tuples. So like this and like this. Oops. What did I do wrong? There we go. Here you can see that it's a list with 2 groups of tuples. It still recognizes it as 2. That's a good clarifying question. The length will look for just the first layer of number of items. Cool. We're almost kind of towards the end. Really quickly, dictionaries have a couple other methods that might be useful. There's a .keys and .values, which, as the name suggests, will get you the keys and values. And they are their own data types, but as you can see, works exactly the same way as a list does. So it has its own type, but it's its own list. So you can iterate through these. Let's say you just need to work with the values, you can do that. But yeah. So here we have the type, you can iterate through them, get like the keys, get the values, and they also work by indexing, because now we've turned, let's see, what's this? We've turned the dictionary.keys into a list. I believe you technically don't even need this list object, but, oh, I guess not. But if we turn this into a list, we can index it. Cool. Just some other little functionalities of dictionaries that might come in handy. All right, last 2 slightly lesser used data collections. We have sets, which are just like dictionaries, but not paired. And the values are always unique. So really quickly, let's take a look at my set. I have 1, 2, 3, 3, 4. If I output my set, it gets rid of the duplicates and just returns you 1, 2, 3, and 4. So actually, just like dictionaries, you cannot have repeating keys. Cool. Now for tuples, the important thing about tuples is that they are immutable. So let's say I have this tuple, and as mentioned before, tuples can be of any length. They're just in round brackets. Let's say I wanted to reassign element 1, so basically like this middle element, if I wanted to reassign that to 4, it's not gonna let me do that because it literally says tuple object does not support item assignment. I could actually do that with a list. So let's take a look at, I think it was called, what is it called, my list? Let's see. Oh, cool, my list is here. So let's say I wanted to replace element 4 with, let's say, reassigned. There you can see a list is mutable. So the difference between a list and a tuple, tuples really preserve the order of your elements, whereas in lists, you can reassign variables. You can reassign elements. So if I were to do the same thing in a tuple, it doesn't support item assignment. Sound good? All right. Questions so far? This is just the last thing with control flows, because we'll get more into control flows in topic 3. Cool. So control flows, just a really quick little problem that we have here. Print out the elements of my list that are integers. So here you can see we have some integers here and some like strings. So for element in my list, and again, this here can be anything you want it to be. To print only the things that are integers, we would have to look, we're basically checking for a condition. So what we would do here is put in an if statement, because we only want to print the element if it is an integer. And how we do that is we nest it in the for loop. We check for if element, actually, if type of element equals integer, then we print element. And I said then we print an element. The then and whatever we do has to be nested within the if statement, so also indented. So there we're printing element, and only the integers will print. So basically, when you're going through 0, 1, 2, 3, they're like, all right, if this passes, let's do this. If, let's say it gets to this string reassigned, it'll see, all right, this is not an integer, it's just not gonna do anything. So let's just write an else statement. So, all right, if it's an integer, let's do that. But if it's not an integer, let's just print not an integer. Or actually even better, we can be element and say is not an integer. Cool. So what we've done here is see that when you iterate through a list, it goes in order because we have 0, 1, 2, 3, and then we have the reassign and be like, oh, this is not an integer. Because it got to this, element now points to reassigned, doesn't hit this if statement, moves on, hit this else statement, and then does this. And basically goes through the same logic flows for the rest of the list. We will get into more logic flows in topic 3. But that is all I had for you for this study group. Any questions? I definitely recognize that there is a lot of information being thrown out here. So feel free to clone this down. If you need help with doing the Git clone, send a message to channel. I think all of us should do that. Actually, yeah, I'm gonna make that like a homework for you guys to Git clone this repo, this study group repo, which basically navigate to this page through homeroom, do Git clone, get this link, ignore this for now. I guess what you'll be doing is basically step 1, but tomorrow I'm gonna walk through what all of this means. So don't worry about that first. Let's just do step 1, fork and clone the repository. Oh my, something I totally forgot to mention. You have to fork the repository first. I'll explain what that means, but when you get here, press the fork button up here. And basically it'll just make your own copy of this. I can't believe I forgot to mention that. I'm gonna type a message with this into the Slack channel, but just fork and clone this repository by tomorrow's study group. And then for our lesson on Git and Bash, we can talk through what all of this means.
Quick question. So the clones don't automatically populate, do they? Because like I cloned before you changed it, will it change my clone too?
Yeah, so good question. When you clone something, it makes a copy of whatever is here at this point. So let's say I make some changes later today and you clone it like right now, you're not gonna get those changes automatically. And actually tomorrow I'm gonna talk about how you are gonna get those changes. And basically this repository, every study group, I'm gonna be uploading new materials, and these are basically the steps to get those new materials. And I'll explain exactly what all of this means tomorrow. But yeah, great clarifying question. Anything else? Awesome. Well, sorry for going over time. There's just a lot of like intro stuff. I know with Python, everyone is sort of at a different place depending on your past experience. So hopefully this was helpful for some of you. For today, I'd say work through topic 1. Start reading through topic 2 if you'd like. Gonna be a lot of Git gibberish, but I'll walk through all of that tomorrow. In the meantime, if you haven't already scheduled your one-on-one, please do. Talk with your working groups. Has everyone gotten their working groups? I hope to see all just subtle nods. Cool. If you haven't yet, let me know. Have you guys been talking to each other? Yes?
Yeah.
Okay, great. Awesome. Yeah. So I really think that like community is extremely important, especially through this like 20-week intensive bootcamp. I think leaning on each other is the best thing they can do. So with that, with your working groups, if you want to meet with me, decide how you want to do it as a group. It's going to change every 4 weeks because I'm going to be rotating these groups with every phase. but decide how you want to do your like group one-on-ones. I guess like 4-on-1s, I guess. I know some groups like to do it like all in 1 hour, like with just a lot of questions once a week. Some groups like to split it into like 2 half-hour sessions. So just know individually you get 1 half-an-hour session, and as a group of 4, or I think there's one group with 5 of you, you get 1 hour as a group. So if you want to like split in like 2 people take half hour, 2 people take another half hour, you can do that too. That's something that you can discuss for sure. All right, any final questions before I log off? Cool. I will talk to you all soon, actually at tomorrow's study group, and I have a couple one-on-ones with y'all today, so I'll see you guys there. All right, bye everybody.
Bye, thanks.